Hey guys, and welcome to the Algebra Part 2 video. Alright, so as you guys may know from the intro video, algebra plays a huge part in the math test. It's over half of the questions are algebra related. So because of that, we have 2 videos to cover all the algebra because there's a lot of things to cover. So we're going to go ahead and start off with prime numbers, and we'll work our way through things like mean, median, mode, ratios, rates, proportions, etc. So first things up, let's talk about primes. So the first question is, what exactly is a prime number? So prime number is a number that can only be divided by itself and the number 1. Another thing to note about prime numbers that's really important, besides the actual definition, is that your smallest prime number is the number 2. Now a lot of people think that 1 is prime, however, part of the definition that you don't really hear quoted all the time is that the 2 numbers 1 and itself must be different. So 1 is divisible by 1 and itself 1, but 1 and 1 are the same number, so it doesn't count as prime. So always remember that 2 is the smallest prime number, not 1. And also primes can never be negative. So it's going to go 2, 3, 5, etc. A lot of times when you're dealing with primes, you're going to be dealing with things like prime factorization. So for instance, they can give you a number and they can ask you what the largest prime is in it. So let's say, what is the largest prime factor of 25, for instance? So when you do prime factorization, you set up the tree that looks like this. So you'd say, okay, it's 5 times 5. Oh, great, only one prime factor, which is 5. And you always stop once you hit a prime factor because a lot of times students will continue doing this. And you could keep going down that tree with the side that has the 5s on it forever and ever. And obviously that's not really so useful for you. So let me go ahead and write down a problem for you guys that demonstrates what you can do with prime numbers. Okay, so here's a pretty typical problem you could see. So how many distinct prime factors do 210 and 84 share? Now, I wrote this problem for you guys because it includes distinct, which is an important vocab term for you guys to know. So basically, distinct just means different or non-repeating. So what we would do here is we would go ahead and start with either number is fine, but 210 was the first one, so I'm just going to start there. And you start doing your factor tree. So because I know that 21 is just 7 times 3, I know that 210 is 7 times 30. Okay, and then I know that 3 is also a prime factor, so I'm going to go ahead and take that out. And then I'm left with 10, which is 2 times 5. Alright, so 210 has 4 distinct prime factors. They are 7, 3, 2, and 5. So now all we have to do is figure out how many different prime factors does 84 share with 210. So our answer is going to have to be 4 or less. Alright, so now we go ahead and do the same thing with 84. So if I'm dealing with 84, it's even, so we might as well divide it by 2. So we have 2, which is a prime factor, and 42. Okay, great, so we can do another 2 out of that. So we've got 2 as a prime factor and 21. Oh, nice, 21. Which 210, 21, very related. So we've got 7, which is a prime factor, times 3. Alright, so 210 has 7, 3, 2, and 5 as its prime factors, and 84 has 2, 2, 7, and 3. So let's look for the ones that they share. So they share a 2, they share a 3, and they share a 7. We already counted this second 2 that's under the 42, 2 times 21, so we can't count that one. And the 5 doesn't go into 84, so we have 3 is our final answer. Another thing that they could ask is for you to find the number of primes in a given series of numbers. So for instance, they could ask you how many prime numbers are there between 30 and Okay, so if I got that question, you should automatically know that even numbers are not prime other than the number 2. So if you're going to list out all of these numbers, you wouldn't start with 30, you wouldn't count 32, but you would count all the odd numbers. So I would say 31, 33, 35, 37, 39, 41, 43, 45, 47, and 49. So those are all of our odd numbers, and then we're going to have to figure out which ones of these are not prime. So the sneaky kind of way to figure this out is that if you can divide any of these numbers by a prime, then the number itself is not a prime. And if I look at my biggest number, 49, I know that that is 7 times 7. So I know that all of the numbers prior to 49 are either going to be prime themselves or divisible by one of the primes, 7 to 2. So 2, 3, obviously not 2 because we got rid of all of them. So 3, 5, and 7 are kind of our options. So we can get rid of 49. All right, so starting from this side, let's just use 3 for now. 33 is 3 times 11, so we can get rid of that one. Let's look at 39 because this actually brings up a cool little rule. Anytime you have a number and you're trying to figure out if it's divisible by 3 or 9, all you have to do is add up your digits. So 9 plus 3 is 12, and 12 is divisible by 3. So we know that 39 is also divisible by 3. So in this case, we've got 3 and 13. So we can cross that out. Okay, great. So then let's go ahead and keep going and see if we can't find anything else that's also divisible by 3. Okay, so our next one, let's try 45. So that is 3 times 15. So we can get rid of 45. So we found everything that's divisible by 3. Now let's look at anything divisible by 5. So anything divisible by 5 is going to end in a 0 or 5. So in this case, 35 ends in a 5. We can get rid of it. So our next question is anything else divisible by 7? And looking through these, doesn't look like anything is. So if it were to ask me how many primes are between 30 and 50, I would say there are 1, 2, 3, 4, 5. 5 primes.